Welcome to my webinar. We're going to be covering web technology literacy today as an introduction to what you would expect to see if you want to start your own web portal. So what is a web page? So a web page is a document that can be displayed in a browser. These three items, HTML, CSS, and JavaScript, would be what I consider the trinity of web technologies. These are the basic things that you're going to be covering if you're going to publish something on the web. However, just focusing on these won't really tell you the whole story. There's a lot more going on to deploying applications on the web. There are programs that translate into CSS, like SCSS, SASS. These are just markup languages, supersets of CSS. There are various standards. For example, ES6 is a newer version of JavaScript, but they still like to be backwards compatible, so JavaScript itself still works. There are frameworks such as React, which help you manage your web pages. Furthermore, there's all the supporting technology in serving a web page. There's clients, there's servers, there's the cloud, there's all important security, and all of these things are critical to hosting your web page. However, don't fear, because you don't need to master all these things in order to host a web portal. Our goal today is to cover the basics of a web page. We're going to cover HTML, CSS, and JavaScript, and what they are and how they apply to a web page. And we're going to introduce you to the basics, but critical security that you'll need to know when deploying a web portal. Lastly, I'll show you a few options for how and where to deploy your web portal. And so the target here is that you won't walk away becoming experts on web programming, but hopefully as per your research group, you'll be familiar with the lingo and the technology when talking to other people about your web page, or where to start if you want to deploy your own web page. So HTML stands for Hypertext Markup Language, and it is the language that defines the content of the web. It provides structure for otherwise unorganized text. There are tags, such as the body tag, that define the role of your text. There are other tags, such as the paragraph tags, that define other roles. There's also tags that simply define how text is displayed, such as the header tag. And the also important anchor tag, which tells the page how to find other pages or connects your page to other pages on your site or across the websites. HTML1 was built at CERN to use and share documents originally. And in 1995, it was expanded, and it first started to show the structure that we use today. It's first standardized tags and added many new tags that we still use. HTML 3 and 4 kind of came out in the same year in 1997, and this is the first time that the standard was managed by the World Wide Web Consortium, where we get the WWW. And this introduced the all-important tables. Extensible HTML stands for Extensible Hypertext Markup Language, kind of a mouthful, and it was a reformulation of the three HTML4 document types to bring them all in to become a subset of XML. Now, today we use what's called HTML5, and it's considered the final version because it's now a living standard. And instead of updating to HTML6, 7, or 8, or so on, they just add features to HTML5. As you go around, you Google and you look for technologies, or you see technologies, you're going to see some old technologies that we don't use anymore. They deserve a bit of honorable mention. ActiveX, Java Applets, and Adobe Flash, these are all things that have come and gone as HTML has developed. So this is an example of a HTML tag, and all HTML tags, it consists of an opening tag, a closing tag, and some sort of content. Sometimes, however, if you don't have any content, you can have what's known as a self-contained or a self-closing tag. And this is just a tag with just an opening and a slash to close it. And lastly, tags can have attributes, one or more attributes that define the behaviors of the tag, but not directly the content of your web page. To create a page, it's quite simply as you go into your editor and you create an index and you end it with HTML, and that is going to become your web page. And in there, you're going to make your the general structure of an HTML page is the outside tags being HTML, and you get header tags, which are not displayed, and then you get body tags, which is the actual content of your HTML page. Inside your head tag, you can have other tags, known as meta tags, which define behavior to your web server, script tags to include scripts into your page, and of course, style tags or link tags to include styling into your page. You can have child tags inside your body tags, such as div, which is your standard division tag, headers, as well as image tags with the source attribute to tell you where to find your assets. These can point to assets on your web server or across the web. And you can also, of course, have the important anchor tag, which tells your page how to connect to other pages so that they're no longer, it's not just static. And that is your basic layout of a web page. In order to make, so that's just the contents, and this tells you what your web page has, but not necessarily how to display it. And that's where we come into cascading style sheets or CSS pages. Cascading style sheets is the role to define, whereas HTML defines the content of the website, CSS defines the look of the website. Here is an example of Wikipedia, where on the left, some of the CSS has been removed, and on the right is all the CSS there. And you can see how they're responsible for color and layout of your web page. So here we're going to start a vanilla HTML document. We'll render in plain black and white. In this case, we have plain text wrapped in a div tag or a div element without any styling. We add a class attribute to the div, and this allows us to refer to it with our CSS. Notice that just adding the class attribute doesn't actually make any changes to the rendered web page. So first we have to add a CSS file, and here we're just going to find a single, though empty, CSS rule. Note that the dot before the square corresponds to, let me grab my laser pointer, the dot before the square corresponds to the class in the HTML document. And this means we're referring to a class, or it refers to the name of the class. But we haven't put any rules or any behavior into this yet. So there's many behaviors, there's many attributes, sorry, that we can set on a CSS style. Background color being a very common one. And once you add that, it will apply it to our div over here and make our text background blue. You can also change the height and the width of an element. And you can apply multiple classes to one element. And here we apply text centering as well as the background width and height. We can have a simple rule to change the font size in div elements. Or here we have a simple rule to change the font size in div elements. Each has an opening and closing brace that defines the body of the rule, as well as one or more key value pairs within the rule. What complicates things is that style sheets are cascading. At the simplest level, it means that the order of the CSS rules matter. So here we have some dummy text and a typical CSS rule that matches the element. So it will make your div elements green. We can add a second rule and it will make them red, and it will override the first rule. You can even add a third rule to change the color again. And this allows for CSS to have multiple rules. However, they can conflict. So now we're going to talk about selectors. There are many, many selectors in CSS, but the simple ones, or the basic ones you'll use most often, are tag name. So we saw div before. There's also span. You can refer to your paragraph P, or your header, your H1, your H2, so on and so forth. You will often in CSS see classes. That's the most popular one, and those are the ones that are preceded by a dot. So dot round, dot centered, etc. And we'll also talk about the ID attribute, and those are rules that are preceded by the hash symbol. So here we have a div with a class and an ID. So this rule here, div, refers to the div element. and it will make the color green. However, we also have a rule that refers to the class of the element, making it red, and also to the ID of the element, which would tell it to go black. And these are all compatible rules that cascade, and some will take precedence over the others. So here, you can also combine rule names. You can combine the class name with the ID by putting the hash name dot name together without spaces. And this refers to our first one up there with the round class and the ID of first. And this one refers to our second one with the class of ID of second and the class of round. And the way that they will render is shown here. We can combine these rules to be very specific. And the general idea being that you can include different class names into your element in order to mix and match behavior. And you'll typically adjust this behavior by using JavaScript. Whereas HTML will be considered the model and CSS is considered the view, your control of your web pages is going to be done with JavaScript. Back in 1994, Netscape was released, but could only serve static web pages. So you only had your HTML. Then in 1995, it was to make the web more dynamic, to make the browsers more dynamic, a scripting language was added. It was originally called Mocha, but marketing geniuses wanted to change it to make it more popular. So it was changed first to LiveScript. And then because Java at the time was so popular, it was named JavaScript. In reality, the scripting language JavaScript has nothing to do with Java other than the name. In 1996, Microsoft created their own reverse engineered version of JavaScript called JScript. This, because Microsoft was such a dominant browser in the market at the time, kind of pushed JavaScript out to the edges because they were no longer cooperating on a standard. However, around this time, ECMA, the European Computers Manufacturers Association, decided to make a standard for JavaScript that, of course, Microsoft didn't participate in. However, around 2008, we get ES5. And in 2000, before that, we got Chrome and Firefox. And because they cooperated together and made for a more cross-platform or cross-browser compliant JavaScript, they complied with the ECMA script. They were able to push out the JScript and start making JavaScript more important again. And this is when the birth of JavaScript really started to take off. We currently have ES6 version of JavaScript as of 2015. And much like CSS and HTML, JavaScript is no longer incrementing in versions, but is again, it's considered a living standard as features are individually added. So JavaScript is a high-level, garbage collected, interpreted, just-in-time compiled, dynamically typed, multi-paradigm, event-driven, functional, object-oriented, single-threaded, non-blocking event loop programming language. And that's a lot of things. It's a very versatile language that does a lot of different things. As you can see by the number of checkboxes we're hitting with this language, we're not going to cover them all today, but we'll just give you a little example of what JavaScript can do. Along with WebAssembly, JavaScript is the only language natively supported in all major browsers. So even if you use a different language, like EJS, which is extended JavaScript, or you use Jinja, which is a Python-based markup language. Sorry, not markup language. It's a Python-based language that gets interpreted. Everything gets turned into JavaScript in the end, with the exception of WebAssembly, which came a bit more recently than JavaScript. You've also got JavaScript has moved beyond the browsers into server-side scripting with Node.js, and moved also onto mobile applications with React Native and Ionic. So you can see that JavaScript is becoming more than just a web language now. It's become a language of its own, and its own separate from its environment. So to start with a JavaScript, here's a little example of a quick little JavaScript program. If you've got this index.html, you've got you got a div and a script. To include the JavaScript in there, you can put the script tag in. I typically put it in the header, but for some reason, this example, I stuck it in the body. It doesn't really matter where it goes. If you put it in the header, it gets pushed to the body by the browser anyways. But either way, when you browse to this page, the script in index.js, which you will also write, is executed, and it executes in the global context. And that means it can share variables and functions with other scripts that have been included in your page. So JavaScript has or the browser more specifically, has a built-in debugger. And you can use this with the console.log to display text to the browser's console. Also, with major browsers, you can press F12 to open up your developer window, and you can see the console. You can see these things that are printed out, along with a lot more information on how your web page is running. One of the major uses of JavaScript, there we go, is to manipulate the DOM, manipulate elements in your DOM. The DOM is just a short word for document object model, and that is how your document is represented in memory inside your browser. So here we have document query selector, and this is where we typically see your index, or sorry, your ID. So index refers to we go back to the HTML. Oops, I didn't include it. It refers to the ID of an element. Now you can save this element, this queried element, either as a var, a let, or a const. Now we don't use var anymore. That's the old-fashioned way of doing things. And we typically stick to just let and const. And let creates a standard rewritable variable that you can refer to again in your program, while const creates a variable that cannot be reassigned. You can also add event handlers to your program. So here is how we allow for a mouse to click, or for you to click on your div just by adding event handling, naming the event and the function. Functions, which are your building blocks of all programming languages. In JavaScript, they're called first-class functions, and that means that they support functional programming styles. You can pass them around like variables and use them in other functions. JavaScript is also object-oriented, and that means that you can have classes which extend parent classes and all your object-oriented niceties. You got statics, constructors, methods, getters, setters, and all of this stuff that you get with object-oriented programming. And you can mix and match these as you feel fit in JavaScript. If you want to have, you can pass in a function to a object and use functional programming where you want, and use object-oriented programming where you like. We're going to talk about, as a precursor to talking about some of the basic security of hosting your web browser, or sorry, hosting your web page, we're going to explain what HTTP is. So HTTP is Hypertext Transfer Protocol, and it defines how your web application communicates between the client and the server. It is the principal protocol used for web communication, and the one that probably gets used the most on a daily basis. It delivers content such as HTML, CSS, and JavaScript to your web pages, but it's also diverse enough that it can deliver images, audio, video, etc. It's quite extensible. There's currently 3 compatible versions: HTTP 1, H1 people call it, or H2 and H3. And they are all backwards compatible. The general idea being that they've made them so that if you use an H2 compatible web server, it's going to be faster than an H1. But they haven't made things so that they're incompatible, so long as you, depending which one, it doesn't matter which one you use. What HTTP does is it allows the communication between your web and your server. So when 2 computers communicate with each other, The client, which is typically your browser, sends a request to your server, and the request sends what's called a response. And these are connectionless and stateless. And that means that once your browser has sent the request and received the response, it no longer maintains a connection. It simply sends a request, waits, gets response, it's done. And your server doesn't remember, it's stateless. It means it doesn't remember what your browser has done in the past. Not by default, sorry, HTTP doesn't. So that you have to put these, if you want these stately behavior into it, you have to add that yourself. By default, it doesn't. And that just makes it very kind of solid. What we'll do is the first thing is you have seen HTTP before, and if you type it into your browser, you type in a web page to your browser, it will automatically prefix an HTTP to it. So here we are, we're going to visit the Wikipedia hamster page. And what happens? We type that in, it creates an HTTP request, and it sends this page to the server. The server then turns that request into a response and sends that back to the browser. This is typically for your HTML page, and your browser will then parse your HTML page and look for your JavaScript script tags, and it's going to look for your style sheet links and stuff like that, and all your images, and it's going to send a number of other responses back to the server, which will turn those into, requests back to the server, which will turn those into responses, sending them back to the browser again. There's a very much back and forth going on. The browser then interprets these into your JavaScript, CSS, and all your assets, and uses those to render your actual page. And the main point takeaway here is that when you send a request for a web page to a server, it's not just one request. There's a whole series of requests, and it goes back and forth many times. And you can see where sometimes you get the slowdown. The more you do this, the more every communication is more time. An HTTP request is just a plain text document, and that's going to become important in a moment. And it works, it's got literally, this is cut and pasted from a request. It's going to have get, which is what action is performing. Get and post are your most popular ones. I believe there's 7 or 8 of them. There's like delete and stuff like that. And then headers. And headers are basically, it's an agreement between your browser and your server on how you expect to behave. So it tells you what we're going to accept back, whether or not we're going to accept text, whether or not we're going to accept JSON, any encodings the browser needs to know. And these are all things that you don't need to know. Your browser and the server, once they're set up, will take care of this for you. It's an important note. Everyone's heard about cookies, and this is where cookies are passed back and forth. They actually exist within the requests and the responses between the server and the browser. If we take a look at a response, it's very similar. It's going to tell you what your protocol is, in this case, H2. It's going to give you some sort of response in this response code, which is 200. And if you've heard of the 404, all that is a response code from the server. And it means we don't have the document you asked for. It's got a bunch of its own headers that is an agreement with the browser on how to behave. And it's got a body, and this body is where your plain text HTML exists. And if you open it up and you take a look at your response, you will see your HTML in there. And this is important because anybody else who's paying attention to the traffic going in and out of your browser, say through your router, or if you're on a public network, can read what you have because it's plain text. And that is why we have secure HTTP. And that is HTTP with SSL, and it's called HTTPS. HTTPS uses a secure certificate from a third-party vendor to secure your connection and verify that the site you are communicating with is legitimate. SSL is an abbreviation for secure sockets layers, sometimes referred to as TLS, which stands for Transport Layer Security. If you hear those terms, they're often referring to the same thing. But what you need to take away from this is that HTTPS is HTTP wrapped in some nice encryption, and it protects your communication from being sniffed or looked at by nefarious third parties. So when we type it in here, the primary difference between before when we typed HTTP is there's going to be an S prefix to it. Sorry, not prefix, affixed to the end of the HTTP. What will happen is what's called a TLS handshake. And this is a couple of back and forth communications between the web and the browser that uses some encryption magic to confirm that the web server you are talking to is who you think it is. It involves some third-party certificates and public-private key encryption. We're not going to get into that today for obvious reasons, but the effect or the final takeaway from it is what you're interested in. And what will happen is when you make the HTTP request, once the handshaking is done, now we've got our public-private keys to communicate with the server, and we can use that to encrypt your request, and your server can use it to decrypt it. And they do the same thing when they send the response back. And that means that anybody who's looking at your communication in between is just going to see encrypted garbage. They're not going to make any sense of it. So when you are on your day-to-day browsing, if you see a little lock symbol, this is from Chrome. I do believe Edge and Firefox have the same thing. And that means that your encryption is solid. That means we're good. Your web pages are encrypted and you can go ahead. To use encryption, and this is what you're going to, on your own websites, you're going to use something called Let's Encrypt. So Let's Encrypt is a certificate authority. And certificate authorities are what servers use in order to, or sorry, rather people who deploy servers, I suppose, in order to verify their certificates. So they are the ones who are responsible for making sure that your certificates are good. Up till now, or up until recently, this costs money. And it was an obscure process that was hard to manage. And usually some sysadmin or someone specialized in this would have to handle it for you. Let's Encrypt is a free, automated, and open source. And that's their goal, that's their mission, is to provide free open source encryption to the world. Because while right now I think something like 70% of websites are encrypted, really they should all be. There's no reason not to encrypt your website. They have encryption itself, what I showed you a moment ago with public-private key encryption, is actually relatively easy. The hard part of HTTPS is authentication, and that is verifying that the certificate you've got belongs to the server you're communicating with, and that's where certificate authorities come in. And this can be a serious pain and financial burden. So Let's Encrypt came along and they automated it. It works with many popular web servers, Nginx, Express, so on and so forth. And usually with a little bit of command line knowledge, you can just do a one command to install your Let's Encrypt certificate. For more information, I highly recommend you go and you visit the let'sencrypt.org website and learn how to encrypt your own websites. We're now going to move on to talking about a software stack. Now, this is just the technology that serves what we've done, what we've already talked about. And you're going to hear things like the LAMP stack or so on and so forth. And that just means what technology, what software you have deployed on your server to run your website. So the first one in LAMP stack, so LAMP is the most popular one. It's probably the OG of software stacks, and it stands for Linux, Apache, MySQL, and PHP. And what the role of those various things are, those are the four basic things you need to run most modern websites. And that's an operating system, that's Linux. You can also use OS X or Microsoft. Linux is nice and open source though. Your web server, Apache is probably the granddaddy, I would say, of web servers. Nginx is another really popular one. Express itself is written in Node so that you can use Node.js to run your web server, do your backend scripting, and run your web pages. You just the benefit of learning just one language. Database is just a good way of storing the data related to your website. if you get a lot of complex data, and that's what the MySQL is. And server-side scripting, PHP, I think is still the #1 scripting language, even though a lot of people have started using other things. And what that is that's a way of manipulating your web page on the server before you send it to the browser. So the browser takes some of the work off the browser and puts it onto the server. And it has the benefit of being able to hide some of the things that you do if it's security critical. So other operating systems, Linux, Windows, OS X, a web server. So I should say that the operating system, you're aware of an operating system simply because you have one on your desktop. Every computer has an operating system, and their role is to run the other software of your web server. The web server itself is what physically serves the files. So when a request comes in, it's responsible for looking on the hard drive, seeing where the file is, and moving it over to the Ethernet to push it out to the internet, where your browser will pick it up and decrypt it. The web server software is responsible for ensuring the communication between the server and the client is secure, and it's a link between the two machines. Once you've got it set up, you don't really have to worry about managing too much of it. You can have someone else manage your web server and you just do the web pages. It's just good to know that they exist. There's other databases other than MySQL, such as MongoDB and Postgres. MySQL is now actually MariaDB, but the two names are generally interchangeable. And they're responsible for kind of being a separate end to store your data, because sometimes your operation can be very data intensive. And of course, server-side scripting. Now, when you get to server-side scripting, unlike browser-side scripting, where there's just JavaScript and sort of WebAssembly, there's a lot you can do on the server side. There's PHP, Node. You can do Java on it. You can do Python. You can have C#. You can even have C. If you wanted to do assembler, you can go ahead. Server-side scripting is just a way of manipulating your web pages on the server before sending them out. Each one is a topic in itself. Now we're going to finish off today just talking about a couple of options. And this might be the takeaway that a lot of people are generally looking for on hosting, is once you've written your website, or once you want a website, where are you going to put it? The first option is what we offer you, and that's our cloud resources. Is that we have a lot of DRAC, Digital Research Alliance of Canada. We have cloud resources that you can ask for and use. If you're a researcher or a grad student supported by a researcher, it's free. That's your benefit. It is hosted exclusively in Canada. However, it is going to be very Linux centric and requires at least moderate Linux expertise, in that you're going to have to set everything up yourself. Your scalability is going to be bound by a rack application. If you want to move anything beyond your basic web server and you need multiple cloud instances, you're going to have to apply for special resources. And of course, it is self-managed. We have a general rule that we don't work on your web server for you, for the general reason that if you haven't backed it up properly and something gets muckered, then you would blame us. It's really a buyer beware. Here's your rope. Go ahead and do what you need. With that, we can help you. If you ask, we can help you back up your data, give you advice on how to keep your data secure and how to keep your server secure. If you don't want to go with us, you can go with commercial cloud. Now, these are going to be very similar. You can get a nice Linux cloud. There's a lot of options. They've got a lot more software as a service available. They are large and scalable, easily scalable. However, they are going to charge you for that. And in my personal opinion, their billing is obscure. Sometimes you're not entirely sure what you're paying for, or you can get charges that you didn't actually agree to. Now, while you get software as a service on a clickable basis, Amazon in particularly can be difficult to navigate, and you're going to have to take a course on using AWS on itself, aside of just doing the actual work. However, it's going to be up because there's a lot of money to be made by these commercial services, and it is an option. In my opinion, it's a little bit overkill for a website. So we move on to GitHub is another offsite option. Now it's free, or at least the base is free. It's easy to use. You just upload your files. If you know how to use Git, you know how to submit a site to GitHub. It has no Linux command line. It is, however, limited to one site per user. So you're going to have one root site. You're not going to have a domain name on it. So if you want a pretty domain name, this is not necessarily optional yet, or you'd have to forward to it. It's limited to front-end code only. So that means your JavaScript, CSS, and HTML only. You can't do any server-side scripting on GitHub. It's a really good entry level. If you just need to put a page up, it's a good option. Now, Linode, I put this on here. It's the one I personally use, and it's a cloud service. Now, the problem is there's a whole slew of website hosting services. You've heard of GoDaddy. That is probably one of the most popular ones. And what they will do is they will start at a reasonable entry level for a commercial cloud. I think GoDaddy is like $2. Linode is $10 for their basic one. Linode will give you a Linux instance, and it's the same as our cloud, where here you go, buyer beware. In that what you do affects you. You have to manage it yourself. It has a benefit. A lot of commercial cloud, like if you go with Amazon AWS, you might not be able to adhere to your data restriction. You might have to host your data in Canada, being a Canadian researcher. Linode, you can ask specifically for a instance in Toronto. It's got a nice dashboard. I think it's a nice blend between some of your more basic command line or cloud dashboards, but not so much as Amazon or Google, where they can just be overwhelming in themselves. However, it's still a paid for service, so scaling up can be pricey. It is Linux command line deployment, so you still have to deploy your own web server, and it's self-managed. There are a number of other web serving options, like I said, GoDaddy, and if you Google it, there's a slew of them, where you can just upload your website itself. Or if you want to do a blog, you can do a WordPress blog, and there's a whole scale of things that you can start with.